Hello, everyone. This is the pre-launch news conference for NASA's Cygnus mission, scheduled for launch on a Pegasus rocket on Monday morning. And here to discuss the upcoming mission, the countdown, and the launch, we have with us Chris Bonnickson, the Cygnus Program Executive from the Earth Science Division in the Science Mission Directorate at NASA headquarters. Tim Dunn, the NASA Launch Director from the Kennedy Space Center's Launch Services Program. Brian Baldwin, the Pegasus Launch Vehicle Program Manager from Orbital ATK. John Scherer, the Cygnus Project Manager from the Southwest Research Institute. And Mike Rabine, the Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. And we'll begin first with Chris Bonnickson. Chris?
Thank you, George. This is an amazing day for NASA Earth Science. As you're aware, NASA's Earth Science Division looks at the processes that make our Earth work, whether that be water or air or the carbon cycle. And in that area, we have an exciting program called the Earth Venture Program, where we look for small, low-cost missions that are doing innovative science. And we do that with balloons and aircraft, and in this case, a satellite. In fact, with the launch of Cygnus, this will be our inaugural mission for the orbital portion of this Earth Venture Program. And as the first clip here showed, this is going to be looking at hurricanes. It's going to be focusing on the surface winds, which is the area of highest dynamic energy in a hurricane, which helps influence how intense the hurricane's going to be. And we're hoping to learn through this mission information that will better understand how those hurricanes grow and intensify. A couple of things that I want to make sure you're aware of is that this uses reflected GPS signals. And that allows us to look through the rain that goes on in the hurricane, which is indicative of the frequency that we're using. Most of the missions that are out there are unable to look through there. So they can only see where it isn't raining. And Cygnus will be able to see where it's raining, what the winds are doing. When Cygnus launches, this is going to be an amazing day, because this is one of our missions that has come on schedule, on cost, and on science. And to me, that is an exciting thing to see, and we are looking forward to getting the operational data here as soon as our Pegasus friends put us exactly where we want to go. George?
Thank you, Chris. Now to Tim Dunn, who's our NASA Launch Director and will be the NASA Launch Manager on Launch Day in the Mission Director Center. Tim?
Thank you, George. I'm proud to be here today representing the men and women of NASA's Launch Services Program. And I'm thrilled to be the launch director for the Cyclone Global Navigation System mission. The data that Cygnus delivers will advance our hurricane forecasting capability, and as a Floridian, I'm personally grateful. Working alongside our Orbital ATK colleagues, the engineers and analysts of NASA LSP take great pride in launching this Cygnus mission. NASA has a terrific record flying on the Pegasus XL. We've launched 19 missions on this unique launch system. Cygnus will be the 20th NASA mission on Pegasus and the 43rd overall Pegasus orbital launch. Cygnus will launch on a Pegasus XL vehicle dropped from the belly of the venerable L-1011 orbital carrier aircraft over the Atlantic Ocean northeast of Kennedy Space Center. Cygnus is what we call a ferry flight mission. We assemble the Pegasus and mate the spacecraft at Vandenberg Air Force Base on the West Coast, and then fly the mated configuration to Cape Canaveral Air Force Station prior to launch. Now I'd like to show a video of the Orbital ATK crew building up the Pegasus launch vehicle and the mated Cygnus spacecraft. Please roll the tape. Here you see earlier this year the arrival of the Pegasus solid stage launch vehicle. Buildup occurs in building 1555 at Vandenberg Air Force Base. There's orbital ATK technicians and engineers working on assembling the rudder fins. You'll see the wing installation taking place here, very delicate operation, handled expertly by our Orbital ATK friends. This is the mating of stage 2, stage 1 here, 2 solid stage of the 3-stage vehicle. And there's the beautiful Cygnus spacecraft, the microsatellites being mated to Pegasus, followed by encapsulation with the payload fairing. That's a nice still shot of the mated configuration. Here we are rolling out just a few weeks ago from Building 1555 at Vandenberg Air Force Base, rolling out the completed vehicle to the runway, the early morning hours there out at Vandenberg Air Force Base. We're headed for the orbital carrier aircraft, the Orbital ATK L1011, affectionately known as Stargazer. You see the launch vehicle with the mated spacecraft and encapsulated payload fairing rolled up under the belly of the aircraft. A lot of detail work going on here, and you see the mated configuration finishing up in this shot. That's a shot early on the morning of December 2nd as we were leaving Vandenberg Air Force Base, and that's a nice GoPro camera view of the flight crew as they're flying into Cape Canaveral Air Force Station skid strip, where we will stage out of on Monday morning. Nice view of the rollout of the L1011 orbital carrier aircraft on its way to the apron, what we call the hot pad area, where we've been for the last about 10 days, completing all of the activities. The Cygnus launch campaign has gone very well. Over the past 3 weeks, the Cygnus Pegasus launch team has been busy with all of these preps. On November 21st, just prior to Thanksgiving, the combined NASA, Orbital ATK, and Cygnus launch team held the flight readiness review, where we assessed all the preps and readiness of the rocket, the aircraft, and range assets, in addition to the Cygnus spacecraft, for that cross-country transport. After mate to the L1011 that occurred on November 28th, we performed a combined systems test with the spacecraft and rocket, and then we flew the L1011 with the mated Pegasus from Vandenberg to Cape Canaveral Air Force Station skid strip on Friday, December 2nd. After arrival, we performed another successful combined systems test last Sunday, followed yesterday with our mission dress rehearsal to exercise and prepare the entire Pegasus team. Orbital ATK participated along with Southwest Research Institute, NASA, and the United States Air Force. Just this morning, we conducted the launch readiness review for the Cygnus mission. Senior managers from NASA Kennedy Space Center, Langley Research Center, and NASA headquarters, as well as Orbital ATK and the Air Force, assessed the readiness of the rocket, aircraft, spacecraft, and range assets to proceed with launch on Monday morning. We had a very successful LRR. We're only tracking one minor item that we expect closure on this afternoon. On Monday morning, the crew will begin arriving on console very early, just after 3 a.m. Eastern Time. We'll then begin all of our final launch preps to prepare the L1011 orbital carrier aircraft for takeoff. After Pegasus power on, aircraft engine start, and ground preps are complete, the aircraft will take off 1 hour prior to launch, fly northeast toward the target drop zone. The launch crew here at Cape Canaveral Air Force Station, as well as the crew on the L1011 aircraft, will perform all of the final preps for Pegasus and the Cygnus spacecraft, including flight termination system checks and spacecraft switch to internal power. Once in the target drop box over the Atlantic Ocean, and after verifying our altitude and airspeed one final time, we'll be ready for the Pegasus release from the aircraft and first stage ignition Monday morning at 8:24 a.m. Eastern Time in our 60-minute launch window. To summarize, the Pegasus XL rocket, the Cygnus payload, and the aircraft are ready, and we will assess the range readiness at our LRR this morning. The combined government and contractor launch team is prepared and excited to launch this important constellation of weather satellites. Back to you, George.
Thank you, Tim. And now to Brian Baldwin, the Pegasus Launch Vehicle Program Manager from Orbital ATK. Brian?
Thank you, George. On behalf of Orbital ATK, we want to let you know how pleased we are to be here at the Cape and to be NASA's launch service providers for this upcoming Cygnus mission. It's been our honor to be here. First of all, I'd like to give you a little bit of what you'll see or what happens after we get to the drop point. I think if we have a tape.
PLT, drop on my mark. 3, 2, 1, drop.
Once Pegasus drops away from the aircraft, at about 2.5 seconds, we'll arm our flight termination system. And then as you see, at about 5 seconds, we'll get motor ignition. During this phase of the flight, our attitude control will be done with our fins as we prepare for this launch. We'll reach max dynamic pressure at about 35 seconds, and the motor will burn for about 73 seconds prior to stage 1-2 separation. After that, we'll ignite the stage 2 motor. We'll then burn for about 38 seconds before we separate the fairing. And once the fairing's separated, we're out of the atmosphere. There's no external loads on the fairing, and we'll continue to burn second stage motor for a total duration of about 73 seconds. We'll then coast up to the proper altitude for about 4 minutes. And once that period's up, we'll separate the stage 2 from the rest of the vehicle, and we'll ignite the stage 3 motor. Stage 3 burns for about 70 seconds, and we use that portion of the mission to help circularize the orbit for the spacecraft. Then at that point, again, once stage 3 burns out, we'll then use our attitude control system to begin orientation for separation of the spacecraft. And these separations will come off in pairs. The first separation will occur about 13.5 minutes after drop, or 13 minutes, excuse me. And then every 30 seconds after that, we'll have another pair of separations. So the final observatories are expected to be separated about 14.5 minutes into the flight. We'll then wait about another 10 seconds and turn off our transmitters, and that will be the end of data flow from the vehicle. And then we'll look for confirmation from the spacecraft folks that they're in orbit. George, back to you.
Thank you, Brian. Now to John Scherer, the Cygnus Project Manager from the Southwest Research Institute. John?
Yeah, thank you, George. Yeah, as Chris Bonnickson said, we take advantage of GPS reflected signals off the ocean surface to measure surface winds. And from an engineering standpoint, that's a very enabling technique. Since we are only receiving signals, we're not having to generate the signals. We're receiving the signals from the GPS, essentially flying radio stations. It allows the spacecraft to be very small. Over here on the left-hand side, it's a full-scale model of one of the 8 spacecraft. And because we're so small, it allows us to fly 8 of these in a relatively low-cost launch vehicle that Tim's providing, and Brian. So I have a couple of videos. First one is the integration of the spacecraft and the flight segment at Vandenberg. So go ahead and roll that, please. So when we arrived at Vandenberg, we shipped each of the spacecraft separately. We went through full comprehensive tests on each spacecraft. We did incoming inspection. That's our QA guy there taking pictures of it. You can see the relatively very small size of the spacecraft. In that photo there, the solar arrays are deployed. We also did solar array deployment on each of the spacecraft. And once we did that, we also did an illumination test to verify that all of our solar array strings were still intact, didn't have any problems electrically. Okay, so now we're into what we call the flight segment, which is composed of the deployment module and the 8 spacecraft. Each spacecraft is held onto the deployment module with a single bolt, and we have this trolley system that allows us to mate each spacecraft to the deployment module. The Pegasus is unique for most rockets in that you have to mate to the rocket horizontally. I think we had this video earlier. This is a picture of the flight segment being mated to the front of the Pegasus rocket. Again, a very delicate operation. And you'll see the black thing in that picture there is the adapter cone. The white structure there is a bridge that basically held everything. This is now in our near flight configuration. We still have solar array covers on. We're in a clean tent again at Vandenberg Air Force Base in California. Again, this is a picture when we're fully encapsulated with the fairing installed onto the spacecraft. So we get launched on the Pegasus, and the deployment module stays attached to the third stage of the rocket. The next video walks through how the separation sequence it will happen. If you'd run the video. So again, here's the flight segment with the deployment module, and underneath us is the third stage. Orbital is responsible for getting us into the right altitude as well as the right orientation. And then it sends a signal when we're in the right place to separate out the opposing pairs of spacecraft. We do it in opposing pairs so that we minimize the disturbance on the flight stack. 10 minutes after the microsat is deployed, the solar arrays automatically deploy. At separation, the microsats turn on, and then we're on our way. And our first contact with the spacecraft, when our job, or the science job actually starts, is about 3 hours after separation. So, George?
Thank you, John. And now for a look at the weather. On Monday, Mike Rabine, the launch weather officer from the 45th Weather Squadron, with our forecast for Monday. Mike?
Well, this forecast is a little bit tricky. We just had a cold front move through the spaceport yesterday, and it is stalled in southern parts of Florida and will be retreating to the north later today and tomorrow. And if we could go ahead and show the satellite loop, you can see that frontal boundary as depicted by the cloud cover over the southern part of Florida. As I said, it will be lifting to the north, and as this happens, warm and moist air will begin to come back into the area, and with it will also come a chance for precipitation. And if we could take a look at the launch forecast, we're looking for light winds out of the southeast at about 8 knots, temperature in the low 70s. We are looking at this point, a 60% chance for violating user constraints. Where the main concern will be flight through precipitation and cumulus clouds. And in the event that we are delayed for 24 hours, we're expecting light and variable winds, mainly out of the west. Again, we are looking at a chance for precipitation, although we are expecting the bulk of that activity to have moved on to the north and east. So we're looking at a 20% chance for violation, again with the main concern being flight through precipitation and cumulus clouds. So we are hoping that we're able to get this rocket launched on the first attempt, and we're going to do everything we can with weather. So, George, back to you.
Thank you, Mike. We're ready now to take questions. We'll start first here in the newsroom, then we'll go to phones for any media that we have calling in, and then we'll take some social media questions. So let's start here first.
Hi, Stephen Clark from Spaceflight Now. A couple of questions. First of all, given the weather forecast, I wanted to ask, are there any what are the differences between the weather constraints for the Pegasus and, let's say, a ground launch vehicle? And are there rules for takeoff of the carrier plane and the drop? And can you walk me through those differences? And also, are there launch opportunities available each day this week? Thanks.
I guess I'll take that. There are launch opportunities available each day until there's conflicts with the range, other users. As far as Pegasus goes, we do have a number of constraints that are associated with our vehicle. One of those being precipitation. We can't fly through rain. The concern is the potential damage to the TPS, the thermal protection system on the vehicle. We can't fly through clouds that there may be issues with lightning or something like that. Now we do. And the the constraint is that we're, at the launch point. So if the pilots and crew are able to fly around some of these cells, we can do that. And at altitude, as long as there's no rain, we're good to go.
I'll just add one thing, Brian. On the range opportunities, we do have Monday and Tuesday secured as a backup day on the range calendar. In the event we should need additional days, we'll go through the normal request process and work with our friends over at the 45th Space Wing Range Scheduling, and we may have additional opportunities as the week progresses.
Bill?
Bill Harwood, CBS News. Just a quick follow-up. For Tim Dunn, you mentioned one issue you were tracking. I was wondering what the issue is. And two, on the weather stuff, I assume, is the precip count on climb out on your L1011, or are you talking about at drop altitude? And I was wondering, what is your altitude at drop? I know it's probably the press kit, but I just hadn't seen it.
The altitude at drop is 39,000 feet. And the concern is not with the airplane, but with the rocket.
Well, you mean you can fly through rain underneath the airplane and not worry about your TPS?
Well, no. We don't want to fly through rain, period.
Okay, that's what I was.
Yeah.
And the first part of your question, Bill, so yeah, we're tracking one minor issue. It has to deal with how we've secured some of the special instrumentation wiring on the Pegasus launch vehicle. It was an open nonconformance. We're tracking that to closure. I don't expect it to amount to anything, and we'll close that out.
James?
Thank you. James Dean, Florida Today. Tim or Brian, you've referred to that drop box. How big of an area is that? I know you said you had some flexibility to kind of move around, but how big of an area is that? And you're also targeting a time 5 minutes into a window. Why is that? And are there, how many opportunities within your window would you expect to have?
Okay. The launch box itself is 10 nautical miles by 40 nautical miles. So as long as we're in the box and we've met all the other constraints, then that's a good opportunity. So we can drop anywhere in that box. Now, what I was referring to about the plane is we still have to drop within that box, but if we can get to that box by flying around, potential weather cells, we have that capability and flexibility that we can do that.
And I think your other question was how many attempts do we think we could go around twice? We'd
That's right.
line up for the target box for the initial attempt, hopefully at the beginning of the window, and then should we not want to drop on that run through the drop box, we have enough time to circle around the racetrack, recycle, and have a second attempt during our 1 hour window. And I think you asked about why do we target 5 minutes into the window, and that's the launch conductor's call on his comfort and working with the crew. And since we have a very generous 60-minute window, and we know that we're only going to get two attempts at it, he just made the request that we go 5 minutes into that drop box window.
Yeah, and it gives us some flexibility. If we have, some issues and we want to drop later in the box, the LC can call that up to the pilots. And we've done that in the past, maybe delayed a minute past our particular drop spot. So that box gives us some flexibility.
Yeah, for instance, the last time we did a Pegasus launch was on the West Coast at Vandenberg. About 3.5 years ago, we did the IRIS mission. We had a 5-minute window that day, and we chose the very middle of that window for our single opportunity. The middle of the window, middle of the drop box.
All right, let's come over here. Ken, you had a question? We'll start right here.
Ken Kramer, Universe Today, Northeast Astronomy Forum. I'm curious, why are we launching now? What is the dictates for launching this spacecraft, this constellation, like right now? We don't have a hurricane right now, so how do you pick that launch window? How long do these spacecraft last? What is their lifetime? And are there plans for a follow-up, since it's a very low-cost mission? Thanks.
I'll start. We're launching now because that way we can get the satellite up, calibrated, and ready for the start of the next hurricane season. Takes us a little bit of time to make sure that it's up and working right. As far as follow-ons, this is a research mission, and the decision for follow-ons will be made once we know that the data does what we believe it will. And that will be worked between NASA and NOAA, since NASA is the research side, NOAA is the operational side. And you ask how long they were going to live? The prime mission, which is what the PI was funded for, is 2 years. After that, it will go into our standard senior review that we look at all of our missions that have gone through their prime to determine whether the science is valid and whether or not we believe that the spacecraft will live long enough to make it worthwhile to continue to operate them, or whether we need to shut them down so that they come back with a controlled reentry to meet all the deorbit and orbital debris requirements.
John, do you have something to add to that?
I was just thinking lifetime of the mission. Our baseline mission is 2 years, but everything on board each microsat is built to last about 5 years or more, and that's with margin. So yes, we are really hoping for extended mission.
All right, another question right here.
Jason Ryan from SpaceflightInsider.com. I'm curious, given the turbulent Florida weather we're so familiar with, why not Vandy or maybe Kwajalein for a launch site?
John? Yeah, so Vandenberg is basically too high of an inclination for us. We could have gone out of Kwajalein. Actually, I was on a Pegasus mission that launched out of Kwajalein, but it's much more expensive to launch out of Kwajalein. It's out in the middle of nowhere. And so it's a lot more convenient to come out of the Cape, and it gets us our orbit that we need, which is the 35-degree inclination.
All right, down here on the end.
Jim Siegel, I'm with Celebration News and Spaceflight Insider. Thank you for being here today. This is an exciting mission, and I'm particularly interested in the craft that you're using, the L1011 Stargazer. Maybe perhaps you can provide a little bit of background about that aircraft. For example, why was it chosen by Orbital ATK when you started talking about launching rockets from an aircraft? And how many other missions could you describe some of the other missions that it's been used on? And I'm also interested in the airframe life of this craft, because I believe it was built in 1972 or something like that. So could you comment a little bit on those issues?
Sure. I'm not the spacecraft or the airplane manager, but I'll give you what I know. You're right. It's one of about 260 or so L1011s that were built by Lockheed. The unique feature about it that we went through quite a trade study in the early 90s on aircraft to use, and the L1011 has a twin hull, which allows us to fit the rocket up snug against the body of the plane, and we have actually a box that we're allowed, that we are able to put that rudder in there. So it's perfectly suited for that. And it's a great vehicle. We're about the last L1011 flying in the world today. There may be a couple others in the Middle East, but certainly the only one in the United States. We've been on a number of. It's a very capable vehicle, so we've been on a number of missions with it. We've been to Spain. We launched for the government of Spain. As mentioned, we've been to Kwaj. So we have to, when we go to Kwaj, we make a stop in Hawaii and then over to Kwaj. We've launched out of Wallops. We've launched here at the Cape, and also at Vandenberg. So it's a very flexible vehicle. Has good range, and it's been a great asset for us.
All right, any further questions here in the room? Bill, follow up.
Bill, again, just one more. I heard you guys talking before this started about whether or not to mention a battery issue, and since you all didn't, I assume it's minor, but I'll ask you what it was anyway. Thanks.
Okay, so we had what was termed a soft short on one of the FM batteries. Again, there's 8 spacecraft. It amounted to about a 3.2 watt load. Nominally, we're about a 60 watt when we're on orbit, so relatively small. The short went away, and we've tested the batteries since it went away, I think 3 days now, done discharge, charge, discharge, charge, and everything seems to be full capacity and ready. So, and another, I think, key thing is to meet our baseline science requirements, we really only need 6 of the microsats to function. So we have functional redundancy in the constellation. They don't talk to each other, but to get the coverage requirement that we have, we only need 6.
All right. Any other questions? One more follow-up here. Right here on the right.
Hi, Jim Siegel again. I'm curious about why this particular mission is appropriate for launch from an airplane as opposed to just a standard launch. Is this just a way of saving money so you don't have a first stage to get it up to 40,000 feet or wherever? Could you talk a little bit about that?
Oh, let me say something and then I'll turn it over to you, Tim. When Earth Science was looking at this, we had a budget for our launch vehicle, and we actually, since this was competitive selected, we gave a weight class as to what people could propose to. And Pegasus is a solid, low-cost mission, and it fits with the overall tenets of Earth Venture. That we want to get innovative science up for the least amount of coinage of the realm. Tim, do you want to say anything about the rocket?
I'll just add on, for the size and the mass of the Cygnus mission, Pegasus was a perfect fit of all of the available launch vehicles in our portfolio of capable rockets that we have.
Okay, James, did you have a follow-up?
Thanks, James Dienfloor today. Tim or Mike, maybe, is there any chance, I know the weather's not looking that great on Monday, but is there any chance people could actually see something off the coast? And then, of course, you have the chase plane. How unique or common is that to get the views that those will provide, or that the chase plane will provide? And finally, just wondered if you could speak to the kind of mechanics of launch. Is it just a push of a button to drop the vehicle, and then is it sort of autonomous from there, or is there another step to light the engines and so forth?
Take that and get me started.
Go ahead and start.
Okay. So as far as what are we going to see from the coast, maybe on a perfect weather morning, you might see a glimpse of something, but we are going to be about 100 miles offshore, almost due east of the Daytona area, so a little bit north of here. So low likelihood to see anything. We will have coverage on NASA TV, and in addition, you mentioned the chase plane. We've brought in the NASA F-18 to do a chase video for us. And when we're capable of bringing assets like that along on Pegasus missions, 3 years ago from Vandenberg, we had that opportunity. You get beautiful video there. So we plan to put that out on NASA TV and broadcast that to the world. Now, as far as how do we actually release Pegasus from the plane, I'll let Brian take that.
Okay, there is, being air launched, it is a unique system. So there is no auto sequencer like you'll see on some of the ground launch vehicles. So it's all man in the loop. We do a couple of things at the very end. 45 seconds prior to drop, we'll activate our fin batteries, and then we'll pull the fin pins. And then we actually do a fin sweep to make sure that everything's operational. So it's a number of things we check. We make sure the launch pressures on the release system are correct, that we've got the right heading, the right altitude, and then the LC, once we're in the box and met all the requirements, the LC will send up a message to the pilot that he can drop. And as you saw on the video, it's the LC that does the countdown. It's the pilot that actually pushes the button to release it.
Question here in the front.
Yeah, Bill Jelen from We Report Space. So when it drops from the L-1011, does the L-1011 turn away? I mean, 5 seconds later, they're actually really close. What is there an evasive maneuver? Or?
They do. They're part of their procedure is to veer off, and so they're about 800 or 900 feet, I believe, lower than the aircraft. We've done all the analysis. You better not quote me on that one. Some of my guys will give me a hard time if I miss the number, but they are instructed to veer off and clear the area.
All right. Do we have any questions on social media? All right.
Yeah, I got a few questions from social media here for you. The first is kind of a follow-on question to a question that was asked earlier, which is, how much does the Pegasus and the Cygnus weigh?
I can tell you what the airplane or the rocket weighs about 50,000 pounds.
And Cygnus, the whole flight stack, is about 300 kilograms.
All right, got another one here for you. How can you translate ocean temperatures by reflecting a radio signal that tells time, GPS?
Well, my recommendation to you is you wait for the follow-on science briefing, and we've got 3 amazing scientists that will tell you exactly how that works.
Sounds logical, all right. The third and final question we have from social media is, how close together will the satellites fly during their mission?
Yeah, so they are, as you saw in the video, they're deployed in opposing pairs. The closest time they ever come together is half an orbit later. And I think our nominal requirement was something like 400 meters. I think on the shuttle it's 100 meters, something like. Anyway, it was a very conservative number. Once we get on orbit, though, one of the things we're going to do is do what we call a drag maneuver. As you can see from the model, we typically are flying in that orientation there, where the 2 antennas are pointing down. And so if you look at the cross-sectional area, it's fairly small. So one thing, even though you're in space, in vacuum, there still is stuff, there's still drag. And so what we're going to do periodically is take a spacecraft, tilt it forward so that the solar rays are facing RAM. Our surface area goes up by about a factor of 7. And so what we can then do is orient the 8 spacecraft around the orbit plane loosely every 45 degrees. I mean, we're basically plus or minus 10 degrees. And that way we enhance our coverage requirement.
All right, we're going to pause now just long enough to change our participants on the dais, and then we'll come back for that mission science briefing. Thank you very much.